Hey everyone, this is my problem presentation for section 7.2. I'm doing number 17. Consider the following initial value problem. Y double prime minus 5y prime is equal to 8 times e to the power of 4t minus 4 e to the negative t, with the initial conditions that y of 0 is equal to 1 and y prime of 0 is equal to negative 1. And our part A asks us to find the transformation of f of t, for which f of t is equal to 8 times e to the 4t minus 4 e to the negative t. So our first step is just going to be to use our known definitions for the transformation. So the transformation of y double prime is going to be s squared times the transformation of y minus s times y of 0 minus y prime of 0. And we'll be using those, so you guys should already know this. But so anyways, let's put it into our problem. So we get s squared times, to be fair, we are focusing on this part. So all we care about is getting the transformation of the right-hand side. So that will be 8 over s minus 4 minus 4 over s plus 1. So therefore, yeah, that's the right answer. And yeah. Okay, our next step is to use the Laplace transform to solve the entire given initial value problem. So using what we had, let's take the transformation of y out of each of our terms, and then we'll get this. Then let's divide s squared minus 5s on both sides, and then we usually get something that looks like this. Our next step is to set up this transformation for partial fraction decomposition. So what we're going to do is multiply. We need all the terms to have the same denominator, so we're going to multiply by s plus 1 over s plus 1, s minus 4 over s minus 4, and s plus 1 times s minus 4 over s plus 1 times s minus 4. And we should get something that looks like this. Now, once we combine all of our like terms and simplify, it will end up being something that looks like this: s cubed minus 9s squared plus 18s plus 48 over s times s minus 5 times s plus 1 times s minus 4. Okay, now our third step is to perform the partial fraction decomposition. Well, sorry about that. So let's take this term and we'll set it equal to a over s plus b over s minus 5 plus c over s plus 1 and plus d over s minus 4. Then we're going to divide by the numerator on both sides, canceling out all the like terms. So we should get something that looks like s cubed minus 9s squared plus 18s plus 48 is equal to a times s minus 5, s plus 1, s minus 4, plus b times s plus 1 times s minus 4, plus c times s minus 4 times s minus 5, plus d times s plus 1 times s minus 5. Now, as you can probably tell, for certain values of s, we can solve for our constants a, b, c, and d. So for s equals 0, we get a is equal to 12/5. For s equals 5, you get 19 over 15 is equal to b. For s is equal to negative 1, you get c is equal to negative 2/3, and for s equal to 4, you get negative 2d. So now what we're going to do is plug these into our equation, and then we're going to solve and finish. So therefore, y of t is equal to the inverse transform of 12 over 15 over s, plus the inverse transformation of 19 over 15 divided by s minus 5, plus the inverse transformation of negative 2/3 over s plus 1, plus the inverse transformation of negative 2 over s minus 4. Then using our inverse transform definitions and rules, we will end up with y of t is equal to 12/5 plus 19/15 times e to the 5t minus 2/3 times e to the negative t minus 2 times e to the 4t. Thank you.